Hello students, we'll be continuing with the third chapter, and today we are going to discuss about periodic properties of elements. Okay, so periodic properties, different properties like valency, atomic volume, electronegativity, electron affinity, and also ionization potential. So the basic definitions and how does it vary across a period or down the group we had already discussed. So most of the topics will be recapitulation, and there will be few important topics where you need to focus. Okay, so the questions, so mostly the questions in 11 will be based on more detailed information from this particular topic. So the first one is valency. So you know what is valency? Valency of an element is defined as the number of hydrogen atoms or the number of chlorine atoms or double the number of oxygen atoms that combine with one atom of the element. So that is the basic definition of valency. And now mostly you can predict the valency after writing the electronic configuration of the element. So in most of the cases, the valency is the number of unpaired electrons, or then the number of electrons present in the valence shell of the element. So let's discuss valency in a little more detail now. Due to similarities of electronic configuration, the elements of a group have the same valency. So how does the valency vary down the group? Now you can see, in the periodic table, in the first group, say in the first group, what you have the elements S block element, where you can see all of them will be having one electron in the valence shell. In S orbital, in the first group they will be having one electron in the valence shell, therefore their valency will be same. So whenever you move down the group in a periodic table, the valency remains same. Okay, now whenever you move from left to right in the periodic table, how does the valency vary then? The valency first increases, as you move across the period, the number of valence electrons increases from 1, 2, 3, 4, 5, 6, 7, 8. If you follow octet rule, then it goes up to 8. So the valency, it increases, becomes maximum, and then again it decreases whenever you move across a period. That means you are moving across the period. Okay, this valency down the group means if they are lying in the same group, like same column, their valency will be same. But whenever an element, different elements are present in a row which is a period, the valency are not same. So you have to remember this part. Now let's move on to atomic volume. So what is atomic volume? Atomic volume of an element is the volume in centimeter cube occupied by 1 gram atom of the element in the solid state, and hence it also called gram atomic volume. So that is the basic definition of atomic volume. Here what you have to remember, you don't have to rot the definition, but you have to remember how it varies, okay, down the group or across the period. So atomic volume is given by this expression, where atomic volume equals to atomic weight by density. Now how does this atomic volume vary down a group? So you are moving from top to bottom in the group. Okay, so atomic volume increases almost regularly in going down a group. You know why? Because as you go down the group, there is successive addition of new cells, and whenever, see, in the first group you will be having one cell. In the first group of the first periodic table, okay, in the first period they will be having one cell. In the second period, now they will be having two cells, and likewise if they are lying in third period, then they'll be having three cells. Now this tells us that the atomic volume increases down the group because there is successive addition of new cells. This is very simple. Now variation of atomic volume across a period. Now whenever you are moving from left to right, so here you are moving from left to right, how does this atomic volume vary? Now, atomic volumes do not vary regularly in a period, okay, because it depends upon mainly two factors. The number one is nuclear charge, and the second one is number of valence electron. So whenever there is increase in nuclear charge, what will happen? The electrons are bound strongly by the nucleus, and hence the atomic volume decreases. So you have to remember, atomic volume is inversely proportional to the increased nuclear charge. Okay, so number of valence electrons. Now here you have to remember, towards the end of the period, now as you're moving from left to right in the periodic table, now as you come towards 18th or 17th, what will happen? 18th or 17th group, the electrons in the valence shell now are more, okay, there is increased in atomic volume. Why? Because there the number of electrons in the valence shell will be more, and because of which there is greater repulsion, among the valence shell electron, and whenever there is increased repulsion, their size or atomic volume tend to increase. Please remember this one. Now let's discuss about ionization energy. So what is ionization energy? The basic definition is very simple. Most of you already know it because the same topic was taught in class 10 also. Okay, please you have to remember factors on which ionization energy depends. Before discussing this, let's recapitulate what is ionization energy. So ionization energy is the amount of energy required to remove one electron from the valence shell of an isolated gaseous atom. So it is the amount of energy required to remove the electron from the valence shell of an isolated gaseous atom. Okay, so now let's discuss about the factors. So ionization energy depends upon atomic size. Now atomic size means what? The size of the atom. Ionization energy decreases with increase in size. Why? Because whenever you have increased size, then the outermost electrons, now you have to imagine over here, okay, so you have let's take two different atoms with different size. Here the positive charge is present at the center, and here also the positive charge is present at the center, yes or no? Now this electron, and let's consider another electron over here. Now in the smaller sized atom, what is happening? This is negative charge. This negative and positive charge, they are nearby each other, because of which this negatively charged electron is strongly held by the nucleus. Whereas in this case, where the size of the atom is larger, then this electron is further away from the nucleus. Okay, and as a result, the force of attraction between this positive charge and the negative charge in the case of larger atom is weaker or smaller, because of which now this electron can be removed easily by spending less energy, and the ionization energy is what? The amount of energy required to remove the electron. Therefore, now here in this case, the energy required to remove this electron is lesser compared to the atom where the size of the atom is smaller. Here this negatively charge is strongly bound to the nucleus, hence you need to spend more energy to remove this electron. Okay, atomic size. So ionization energy decreases with increase in size. This is clear. Now nuclear charge. Now you should be able to tell me how ionization energy vary. If there is increased nuclear charge, then the outermost electrons will be strongly bound to the nucleus. That means you need to spend now more energy to remove this electron. Hence ionization energy increases with increase in nuclear charge. Okay, the third point is screening. Screening means, the definition, you have to remember what is screening effect. Screening effect is what? The reduction in force of attraction by the cells present in between the nucleus and the valence electron is called screening or shielding effect. For example, suppose you have, say, the nucleus is present here at the center now, and you have the outermost electron over here. Now there are other cells present in between. Okay, now here the barrier, the electrons present here in this cell will act as a barrier between the negatively charged electron in the outermost cell and the positively charged nucleus at the center. Now these electrons in between, they act as what? A barrier. The barrier which is possessed by this cell in between is known as what? Screening effect. And this now will interfere with the force of attraction between the nucleus and the outermost electron, the electron lying in the outermost cell. Okay, now this will reduce the force of attraction between the nucleus and the outermost electron, and hence now this electron can easily be removed. Okay, so you have to remember what is the screening effect. The reduction in force of attraction, there is reduction, you have to remember there is reduction in the force of attraction by the cell present in between the nucleus. You can see here this cell is present in between the nucleus, and the valence electrons are not strongly bound to the nucleus. Now more the screening effect, more easily this electron will be removed, and lower will be the ionization energy. And why lower will be the ionization energy? Because it is the amount of energy required to remove the electron. Okay, and the last point that we have is stable electronic configuration. Now I have already taught you what is stable electronic configuration. Here, half filled and fully filled orbitals or subcells are stable. Now whenever in an atom they have either half-filled configuration or fully filled configuration, then those atoms will be very, very stable. And if they are stable, what will happen? The electrons cannot be easily removed. So based on this ionization energy, there are different questions which are very important, and among them these three questions, or the reason for these three questions, are very, very important. Like, ionization energy of nitrogen is greater than that of oxygen. So as you move from left to right in the periodic table, what will happen to the ionization energy? Ionization energy will increase. And as you move from top to bottom in the periodic table, ionization energy will decreases. Okay, here now this information, this is the trend, general trend, how this ionization energy vary in the periodic table. But here this is in contrary to this general trend. Why? Because nitrogen comes first, then comes oxygen. Yes or no? So according to this trend, oxygen should have been possessing more ionization energy, but actually nitrogen has more ionization energy than oxygen. And what is the reason? The reason is this fourth point, stable electronic configuration. So let's write the electronic configuration for nitrogen. Nitrogen is 7, so 1s2, 2s2, 2p, 2p3. Yes or no? For oxygen it is 8, so it is 1s2, 2s2 and 2p4. Now whenever you write this in orbital form, then it will be more easier to understand. Now see, Here p orbital has 3. Now these electrons are present here as 2, then in p orbital you have 3 electrons. Yes or no? So this is your 1s, this is 2s, and this is 2p. Similarly for oxygen, you have this 3 orbital itself, 2 electrons, 1 2 3 4. This is s1s, this is 2s, and this is 2p. Now here you can see that in case of nitrogen, the 1s orbital is fully filled, 2s orbital is fully filled, and 2p orbital is half filled. 3 boxes are there and each of them are singly occupied. The maximum capacity for p orbital is what? 6 electron. Here it is half filled. This is half filled. Yes or no? This is half filled. And as the fourth point tells us what? The fourth point tells us half filled and fully filled orbitals are stable, and in case of nitrogen it is half filled, therefore it has stable electronic configuration. Similarly, now in case of oxygen, this 1s and 2s are fully filled, but in case of p orbital it is neither half filled nor fully filled, therefore the electronic configuration of nitrogen is more stable. If it is more stable, then it is very difficult to remove the electron, or in simple words we can say that the electrons in the outermost shell can be removed by spending more energy. That means its ionization energy is greater than that of what? Oxygen. Hope this explanation is clear. Now in your book you have ionization energy of neon is greater than that of fluorine. Explanation is given in the book. Please refer to the book. Similarly, for this third point, that is ionization energy of beryllium is greater than that of boron. So here also we can have the same explanation. The fourth point gives us the answer for this particular question. Okay, because beryllium, again, it is based on half filled and fully filled orbitals, and in your book you write the electronic configuration and you will understand it, and in the book the explanation is given properly. Please refer to it. Now let's move on to the next property, that is electron affinity. So what is electron affinity? So electron affinity, you can tell it, this is just the reverse of, or the just opposite of ionization energy. Electron affinity, here we need energy. We don't need energy. The energy will be released. Its energy will be released. You have to remember. So what is electron affinity? Electron affinity is the amount of energy released when an electron is added to the outermost shell of an isolated gaseous atom. So this is just, as I told you, this is just the opposite of ionization energy. Here energy will be released. Please remember. Now let's discuss about the factors on which electron affinity depends. The first one is nuclear charge. Greater the nuclear charge, higher will be the electron affinity. Okay, you have to remember this. More nuclear charge means what? The incoming electron can be easily attracted to the outermost shell. Therefore, its electron affinity will be higher. Similarly, size of the atom. Now, smaller the size, greater is the electron affinity. So, if you have a smaller size of the atom, then what will happen? The incoming electron is affected by the nuclear pull, so they can come easily to the outermost orbital or the outermost orbit. So if size is small, that means electron affinity will be greater. Now here, electronic configuration. Please remember this. An atom with stable electronic configuration, that is octet or diplet, and has no tendency to gain an electron, such atoms have zero or almost zero electron affinity. So if an atom is already stable, that means it doesn't have any affinity for electron, and in such cases they are said to have either zero or almost zero electron affinity. Okay, and here electron affinity of beryllium, magnesium and nitrogen are positive. Why? Because beryllium and magnesium have fully filled s orbital and nitrogen has half filled orbitals respectively. So they are these elements like beryllium, magnesium and nitrogen. You can write the electronic configuration. For nitrogen I have already written in the previous topic, that was ionization energy. They have, this has, nitrogen has half filled orbital, whereas beryllium and magnesium, they have fully filled s orbital, and because of which they are highly stable. They do not have any affinity, they do not have any affinity for electron. Therefore they are said to have either zero or positive electron affinity. And as you know, as you move from left to right, in the period, what will happen? Electron affinity increases, it increases, and as you move from top to bottom in the periodic table, it decreases. Okay, so halogens, they have the highest electron affinity. You have to remember this. Why? Because halogens, they lie in the 17th group and they have 7 electrons in the valence shell, because of which if they gain one more electron, then it becomes what? If they gain one more electron, then it becomes 8. Now 8 is octet configuration, and once they have octet configuration, they become highly stable, and because of which their electron affinity, the electron affinity of halogens are very, very high. Now the next periodic property that we are going to discuss is electronegativity. Okay, so electronegativity is what? It's the tendency of an atom to attract the shared pair of electron towards itself. So what is electronegativity? Electronegativity is the tendency of an atom to attract shared pair of electron towards itself. So that is the definition of electronegativity. Now let's discuss about the factors on which this electronegativity depends. The first one is size. Okay, the first one is what? Size. Smaller the size, the greater is the attraction for bonding electrons, hence more is the electronegativity. So if the size of the atom is small, that means their electronegativity will be higher or more. Similarly, if you have more nuclear charge, then again the electronegativity will be higher. Okay, cations has higher electronegativity than its parent atom. For example, you have, say, sodium. This is sodium, this is an example. Sodium is atom and this is sodium cation. Now this sodium cation will have more electronegativity than sodium, whereas anion, example of anion, you have chlorine, and let's take chlorine anion. The chlorine anion is having less electronegativity than the parent atom. Parent atom is what? Chlorine, and then Cl minus is anion. This Cl minus electronegativity is much less compared to the chlorine atom. Okay, the fourth point that we have is elements having higher value of ionization energy and electron affinity also have higher value of electronegativity. So if an element has higher ionization energy and electron affinity, they tend to have higher value of what? Electronegativity. Please, you have to remember these points. Now how does electronegativity vary? Electronegativity varies. Now whenever you move from left to right in the periodic table, it increases, it keeps on increasing. Okay, the electronegativity, it increases due to increase in nuclear charge and decrease in atomic size. So nuclear charge, with increase in nuclear charge, electronegativity increases, and with decrease in atomic size, electronegativity again increases. Hence, in moving from left to right in the periodic table, electronegativity increases. Please remember. And when you move from top to bottom in the periodic table, it decreases for S and P block elements due to increase in atomic size. So for S and P block elements, this electronegativity, it decreases as you move from top to bottom in the periodic table. Why? Because their size increases. Why the size increases? Because there is addition of successive cells, and as a result of which their size becomes bigger. And you know, fluorine is the most electronegative element known. Please remember this one. The last topic that we are going to discuss is diagonal relationship. So the definition is given, but for understanding we have to take the second period and the third period. Okay, so from the second period, in the second period you have lithium, beryllium, boron, carbon, and in the third period you have sodium, magnesium, aluminum, silicon, and likewise. And what does this diagonal relationship mean? The chemical property of lithium and magnesium, see, they are almost same. They are lying diagonally. Can you see it? So similarly, this beryllium is diagonally related to aluminum, and these properties, chemical properties, are almost similar. Similarly, boron and silicon are diagonally related, and their chemical properties are almost similar. So this is very simple. What is diagonal relationship? Among the elements of second period and the third period, the diagonally related elements, their chemical properties are almost similar. So here is the definition. I hope you understood this one. The first member of first group and the second member of this following group, so similar properties. For example, the chemical behavior of lithium is similar to that of magnesium. So lithium and magnesium, they are diagonally related and their chemical properties are similar. Similarly, magnesium and lithium we just discussed. Beryllium and aluminum will also have similar chemical properties. This sort of similarity is commonly referred to as diagonal relationship. So this similarity in properties between these diagonally related elements from the second period and the third period is referred to as what? Diagonal relationship.